Here we have a question. A horizontal bridge is built across a river, and a student standing on the bridge throws a small ball vertically upwards with a velocity of 4 meter per second. Let's say this is the level of bridge and this is level of water surface in the river. And from here, let's say the small ball is thrown vertically upwards with initial velocity of 4 meter per second. So the question is, what is the height of bridge above the water surface? Means we have to calculate this height. And we have another piece of information, which is the total time during which ball moves in the air is 4 seconds. So how the journey of the ball we can consider. Let's say at first the ball will go upwards, and then after reaching at some maximum height where its final velocity will be zero, it will start descending, and then it will hit the water level. So we can split the entire motion, entire journey into two parts, one above the bridge level and one below the bridge level. So let's check what are the parameters we can go through so that we can obtain the height. So if we know the velocity at which the ball descends from the bridge level, let's say it is V1, and the time taken which we can obtain by the ball to reach the water surface, let's say this is T1, then we can find out this height is. So first we will calculate the velocity. Let's say in the first part where the ball is moving upward, after reaching at maximum height, the velocity of the ball will be 0 meter per second. So we can calculate the time taken to reach the maximum height, which we can calculate as V equals to U plus AT. Here A is nothing but G, and we can write U is 4 meter per second and V is 0 at maximum height, plus let's say G equals to 10 as given here. So into T. Why I'm taking minus 10? Because here acceleration due to gravity is in the opposite direction to the direction of velocity or to the direction of motion. So it will be, T will be nothing but 4 by 10 second. And we can calculate easily from this point, if this ball starts descending, it will take the same time to reach back to the bridge level. So the time of descent will be the same, 4 by 10 second. So total time of flight above the bridge will be twice of this time, which is 8 by 10 second. Or we can simplify it to 4 by 5 second. So this is the time during which the ball goes upward to the maximum height and then comes back to the bridge level. Now, the total time duration is 4 seconds. So we can obtain the time taken by the ball from bridge level to reach the water surface, which we can calculate easily, which will be 4 minus 4 by 5 second, which will be 16 by 5 second. Now we have to mark this time, and let me remove these things. So this is the water level. So we have time here, t equals to 16 by t1. Let's say t1 equals to 16 by 5 second. This time is uh, the time duration taken by the ball to reach the water level from the bridge. Now we can calculate what velocity, with what velocity it starts from the bridge level. That is, you can calculate u1, and this u1 will be 4 meter per second. If you want to calculate it, you can calculate very easily. How it can be calculated? Let's say at maximum height, it has velocity 0 after reaching maximum height, and from there it starts descending, and then we have acceleration due to gravity, and we already have calculated t. So from this we can calculate the velocity 4 meter per second. You can do it by yourself, and still you have any problem, I'll explain that later. You can mention that thing in comment. So this is easy one. Now we have velocity here. We have time duration, which is 16 by 5 meter, sorry, 16 by 5 second. So we can calculate this height h, which is nothing but ut plus 1 by 2 g t squared. So u is 4 into t, which is 16 by 5, and 1 by 2 g, which is 10. This time the motion is along the downward direction, and the acceleration due to gravity is also along the downward direction. So I have taken positive 10 here. And here we will have 16 by 5 whole square. So we can take common 16 by 5. Then we will have here 4, and here we will have uh, 5. So 4 plus 5 into 16 by 5. 116 by 5. Here I have taken common. So here is a square term. So it will be 16 by 5 left here. So this will be 16 plus 4, 20. So 16 into 20 by 5, and ultimately it will be 64. And as everything is in SI unit, look here, velocity is in meter per second, time is in second, so, and acceleration is in meter per square second. So at the end we will have uh, this distance h in meter. Let's take another example here. Okay, so we have another question. A vehicle travels half this seems very easy. A vehicle travels half of the distance with speed v, and the remaining distance with speed 2v, and we have to find its average speed. So let's say the vehicle is traveling from point A to point B, and there is another point, midpoint here, C. Let's say this distance is x, and this is also x. So if the vehicle is traveling this distance with speed v, and this distance with speed 2v, so time taken will be, in first case, it will be x by v, and in second case, it will be uh, x by 2v, and then total time will be t1 plus t2, which will be x by v plus x by 2v, and then we will have x by v common 1 plus 1 by 2, which will be 3x by 2v. This is total time, and total distance is x plus x, which is 2x. So average speed is nothing but total distance by total time. Here we can write total distance by total time, 3x by 2v, and then we will have uh, 4 times v divided by 3. So this will be the average speed, and uh, there is no specific unit mentioned here. So whatever be the unit here, that will be okay. Let's try another question. It is also the easy one. So what is happening here? The ratio of the distance traveled by a freely falling body in the first, second, third, and fourth seconds is. So how can we calculate? As we know, h equals to ut plus half gt square. Let's say body starts falling from a level here, and at t equals to 1 second, at what distance below its original level it will be. So here, let's say this one is h1. So h1 will be, so h1 will be ut. U is 0, let's say, if we are dropping the body from here. So 0 meter per second. So the first term will be 0, here square term, and then 1 by 2 g to 1 square. We can calculate here. This will be, now if we move for t equals to 2 second, everything will be common except this time. So on checking the pattern, we will get that h is nothing but 1 by 2 g t square, or this thing is constant. So we can say h proportional to t square. Okay, let's complete it first, then we can build a better idea. This will be 1 by 2 g and 1 square for the first second. So this will be 1 by 2 into g only. And here 1 by 2 g, and t2 is 2 seconds, so it will be 4. In the same way, next S3 will be 1 by 2 g, t3 square, where t3 will be 3 seconds. So in the same way, it will go on. Let's check. So we can write S1 equals to 1 by 2 into g, S2 equals to 1 by 2 into g into 4, and similarly S3 equals to, which will be the distance here, S3. So it will be 9, and H4 equals to 1 by 2 into g into 16. Now we can just take these separations, and we can say how much distance it is covering in each and every interval. So in the first interval, suppose it is covering g by 2. In the second interval, it is covering g by 2 into 4 minus g by 2. This one, this one, this one will be h2 minus h1. So minus g by 2, that will be 3 g by 2. So in the same way, here we will have, in the next interval, we will get 5 g by 2, and in the next interval from h3 and h4, we can get h4 minus h3, which will be 7 g by 2. So we can check here, it is in the ratio of 1 is to 3 is to 5 is to 7.